Okay, welcome to lesson 6.3. In this lesson, we're going to be talking about scalar multiplication of vectors. So when I take a scalar amount and I multiply it by a vector. We've already kind of seen some of this. We're just going to go a bit further with it today. So I'm given a non-zero vector v, so that just means it has some magnitude, not zero, and some number k that does not equal zero. So notice that k is not a vector, it's just a scalar. There's no vector notation with it. So then I have k times the vector v. It's going to be a vector with the following properties. It's going to be, so we're talking about kv here, it's going to be parallel to vector v. And another way for me to say that is that kv and v are collinear vectors. It's going to be k times as long as vector v. So notice that we're taking the absolute value of k. So if this was like -5, then it's going to be 5 times as long as vector v. I don't care about the direction, I just care about the magnitude. Kv is going to be in the same direction as vector v if k is greater than 0. And if k is less than 0, so if k is a negative number, then it's going to go in the opposite direction as vector v. All right, so let's see an example here. We're given two vectors, vector A and vector B. There are slightly different magnitudes, and A is pointing kind of down to the right, B a little bit up to the left. We're going to construct these three new vectors based on them. So in example A, it's going to be 2 times vector A. So it's a scalar multiple. What I'm going to do is grab my ruler, and I'm going to line it up with vector A. And I'm going to measure it out. So this one here I see is about 4 centimeters long. And I'm going to draw a new vector that's twice as long. So it's going to have double the magnitude, but it's going to go in the same direction. So I'm not changing the angle of my ruler. I'm just sliding it over, and I'm going to go twice as long. So it was 4 centimeters. Now I've got one that's 8 centimeters. It was 4, right? I'm just going to double check. Yeah, it was 4. Okay, and then I need to show which direction is it going. Is the arrow on this end or is the arrow on this end? It needs to go in the same direction as vector A. So down here. And then I can label my vector. This is 2A. All right, next one we're going to do is -1/4 times vector B. So again, I'm going to take my ruler, line it up with vector B. I see here that B is about, hold on here, it's about 2.8 long, so I want to take 1/4 of that, so half would be 1.4, and then half of that would be 0.7. So I'm going to draw a vector that's about 0.7 centimeters long. I'll do that. I'll just do that underneath here. I've got lots of room down here. And I mean, like when I mark a question like this, I'm not going to be looking for exact, but about 0.7, right? That's what I would be doing. I would grab my ruler and line it up with yours. Now this example has a negative in front, which tells me that I need to go in the opposite direction. So the old vector pointed up to the right, or to the left, sorry, and now I'm going to go slightly down to the right. And this is my -1/4 of vector B. All right, and then in our last example here, we're going to do 2A's minus 3B's. And so I'm going to start by drawing 2A's. Now I've already got that here, so I'm just going to copy it. There's my 2A. We'll change the color for this example. There you go. There's C now. I need to add my arrow to the end. So there's 2A. And to that, what I'm going to do is tack on, and I'm starting from the head here, -3B's. So remember that we said here that B is about 2.8. I'm going to do that 3 times. And I'm going to go in the opposite direction. So it's going to be pointing down towards the bottom right. And I'm going to tack that onto the end here. I hope I've got enough room. So I'm going to be doing the 2.8 3 times, so I need to get to 8.4. I just have enough room here. All right. And I tacked it on there, but it's switching direction, remember? So instead of the arrow being up on the left, it's down on the right because I had a negative. So here's my negative 3b, and from that I can create my resultant vector. That's what we're asking for, right? We've got the vector addition or vector subtraction here, and so I need my resultant vector, which is going to come from this tail here and end at this head there. So grab your ruler and line that up, or I'm going to use my straight line tool, and that's my result. All right, so in the box here we've got a bit of a definition. We're talking about what is a unit vector, and we did mention that briefly in the last lesson, or in the vocabulary lesson. A unit vector has a magnitude equal to 1. So what we're going to be looking at in today's lesson is how can I create a unit vector out of any old vector. So if I have some vector x that is not the 0 vector, so it has some magnitude, maybe it's got magnitude 5, say, then I can make it into a unit vector by multiplying the original vector x by 1 over its magnitude. So let's see an example here. For example, if the magnitude of vector x, that's what this says, the magnitude of vector x is equal to 6, then if I do 1 over the magnitude times the original vector, I'm going to end up with a unit vector, right? If it was 6 units long and I take 1/6 of it, then I have 1. And it's going in the same direction. All right, so let's try a more complicated example here. I've got two vectors, m and n. M has a magnitude of 6, and n has a magnitude of 2. The angle between m and n is 60 degrees. Remember when they say angle between? I mentioned this earlier. The angle between is always between two tails, or it would be exactly the same if you looked at the angle between two heads. But they're not lined up and ready to add is basically what's happening here. We need to determine the unit vector in the same direction as m plus n. Okay, so I'm going to grab my ruler and I'm going to draw these two vectors. So I'm going to just draw my m pointing kind of down, just for the sake of space here. And m has a length of 6. And I don't have to use 6 centimeters, right? Like it could be 6½ centimeters, so you could just draw 3 centimeters. It doesn't really matter as long as it's whatever it is, n is 1/3 of it. N is only 2 long. Now the angle between m and n is 60 degrees. Now I'm not going to check your angle here, but this angle here, I'm looking starting at the line I just drew to this far edge of the ruler. It should definitely be between 45 and 90 degrees. That's what I'm going to be looking for. You know that it's more than 45, but it is less than 90. And over here I'll draw something about 2 units long. All right, so I've got my drawing. Now remember that the angle 60 degrees is either between two tails or two heads. So I'll put it between the two tails, but it would have been the same if I'd drawn it the other way with the heads pointing together. Now, what I want to figure out is the unit vector in the same direction as m plus n. So we've got vector m here and vector n here. We want to figure out m plus n. So in order to add two vectors, I need to drag that vector n down and connect it to the head. So the tail of vector n is going to touch the head of vector m. Okay, so this is another version of vector n. Remember, I can just drag it around the page as I like. Now what I want though is the vector that, that represents the sum of these two. So I'll draw that in green here. It's going to go from the tail of m to the head of n. I'm just going to emphasize that this here is my arrow, and this is m plus n. Okay, now in order to find a unit vector in the same direction, I've got it drawn here, and I do know the direction of the unit vector is in the same direction as m plus n. What I need to figure out is what's the length or the magnitude of this vector so that I can create a unit vector. So in order to find the magnitude of this, I'm going to use that same cosine law idea that we had the other day. I know that the magnitude of vector m is 6, so the side length here is 6. The side length is 2. I wish I knew this angle in between them, and then I could use the cosine law. But I do know that angle. I know that if it's 60 degrees up here, the C pattern, because the top and the bottom here are parallel, tells me that this is 120 degrees. Or you can think about it if I extended out. If I extended out vector m here, this angle in here would be 60, and so then adding these two together, I should get 180 degrees in a straight line. Either way, however you come up with that, it's 120. So we're going to use the cosine law here. And remember, my goal is to come up with 1 over the magnitude of this thing times itself. That's going to be the unit vector. So this is my goal. All right. The cosine law, in case you've forgotten it, again, is c squared equals a squared plus b squared minus 2ab cos c. I'm going to fill in my vector stuff here. So we're going to be finding the magnitude of m plus n squared is equal to, and so here I'm going to be thinking about a as my vector m, and the magnitude of that is 6. The vector b, or b is the same as the magnitude of vector n, so that's going to be 2 squared. And we said the angle in between them was 120 degrees. All right, we're going to type that all into our calculator, and I'm going to get 52. And so then in order to get rid of the squaring on this side, I'll bring it over and square root. I'm only worrying about the positive square root since I'm talking about a side length. And then I can simplify this. Remember that when I have a radical, I look for things that are easily square rooted, since I'm dealing with a square root, to pull out of here. So I think about numbers that are easy to square root are 1 squared, 2 squared, 3 squared, and I go through the list here. So this is like 1, 4, 9. And so I'm just thinking, what can I divide out of 52? And I can divide 52 by 4. So 52 is the same as 4 times 13. And then I can pull that square root of 4 out. That would be 2, and I'm still left with the square root of 13. And so therefore I can actually state my unit vector. Remember, that's all I wanted here was my, my magnitude. So therefore the unit vector I do 1 over the magnitude times the original vector. And that'll give me a unit vector. Okay, in example 3 here, we're looking at two vectors x and y are both unit vectors. So I know that they both have a magnitude of 1, and they make an angle of 70 degrees with each other. So again, that's going to mean tail to tail or head to head. We want to find the magnitude in the direction of vector z, which is x minus 5y. So first I'm going to draw a quick picture of my x and my y. So perhaps I've got x here, and then my y would be 70 degrees from it with the tail. They're both about 1. Notice I'm not using a ruler in this example here, but you could line them up and with your ruler measure out, say 5 or 1 centimeter. So I'm going to call this vector x and this vector y, and I've got 70 degrees in between them. Now I'm going to try to draw vector z, which is made up of an x. So I'm going to copy my x. and I'm going to tack on negative 5y. Now I want to start from the head here and draw negative 5y's. So I'm thinking about this vector here. I want to kind of line it up on the same angle, but I'm going to switch the direction, right? Because I'm thinking about being negative y. So I'm going to switch and put the arrow on the other end, and I'm going to line it up with the head. So now I've got the head lining up with the tail, and then I'm just going to drag this out so that it's 5 times as long. So something like that. I'm not measuring here, but I'm getting 5-ish, like 1, 2, 3, 4, 5. Close enough. I want to make sure that my picture gives me some sort of accuracy when I'm doing my calculation, so I'm not totally thrown off. So here's my negative 5y, here's my x, and now I need to figure out what the angle here is in between them. Now remember, we started by flipping the direction of this and making this negative y, and now that 70 degrees is actually between a head and a tail, so that's actually the angle that I'm going to use here. I didn't have to do the 180 minus. And so what I want to do is figure out what vector z is. So vector z is starting at the tail and going to the last head. There's vector z. I want to know the magnitude and the direction. So again, we're going to start with magnitude. I'm going to figure that out using the cosine rule. So here's my magnitude. Here I'm not going to write out the basic cosine rule. I'm just going to go right into substituting in. I know that the magnitude opposite it is 5 because it's 5 times a unit vector. And this one over here is a magnitude of 1. And the angle opposite vector z is the 70 degrees. And then I'm going to type that into my calculator, and I'm going to get 22.58. I'm going to square root this to get just vector z by itself, the magnitude, I should say, of vector z. And this is coming out to approximately 4.8. And I just checked the picture, like, does that kind of check out with my picture? Yeah, if this was 5 long, that looks like it's pretty close in length, so that makes sense to me. Next, we're going to find the direction of vector z. So to find the direction, we're going to use the sine law. Now I have a pair across from each other, angle, and its side across from it. So I want to use this side length here to find the angle here at the tail. So I'm always focusing on the angle at the tail. When I do this, this is my theta. So I'm going to say sine of theta is opposite the side length of 5, and sine of 70 is opposite the side length of 4.8. All right, I'm going to solve by bringing the by bringing the sine theta and the 5 over. So I bring the 5 up and multiply it. And then I'll take sine inverse of this. All right, when I type this into my calculator, I get about 78.2 degrees. And when I look at this picture here, actually theta looks like it's greater than 90 degrees. And so what I'm going to do is realize that the cast rule, it's giving me this angle here of 78 degrees, but what I actually want is an obtuse angle, and the sine ratio is positive for an obtuse angle, and that's why your calculator gets mixed up, and we call this the ambiguous case in grade 11 math. Right? We covered this in 3U, and so it's actually this obtuse angle that I want, and so 78 is also the angle in here, and so I'm going to do 180 minus 78 to figure that out. And so I just used the picture to help me realize that I actually wanted an obtuse angle here. And so then I just figure out the other angle. And again, just 180 minus. And so that comes out to about 101.8 degrees. And then I can write my sentence. Now, be careful here. A lot of people love to tell me the angle of Z relative to northeast, southwest in these types of questions. You can't use northeast, southwest. I chose to draw angle X pointing up here, but vector X could have been pointing straight to the west, or maybe it was pointing straight to the south. You have no idea where it was originally pointing. So you can't tell me that you know where angle Z is pointing in terms of northwest, south, and east. What you can tell me, though, is where it is in relation to vector X. And that's what we're going to do, is we're going to state the angle between Z and X. That's what we figured out. So my answer has to be in terms of one of the other two. And we're going to talk about the tail-to-tail measurement. Otherwise, you could figure this one out, but then you'd have to figure out the actual angle between the tails of Y and Z. So you'd have to kind of drag Z up and figure out what that angle was. All right, example 4, we're given two vectors u, and v is actually a scalar multiple of u. It's negative 2/5 of u. We want to find values a and b such that a times vector u plus b times vector v is equal to 0. Okay, so I'm going to start with subbing this in to this expression. Right? As soon as I can combine two equations, I'm going to do that and see what new information I get. All right, so I'm going to try to simplify this. This second vector u has a coefficient of negative 2/5 b, whatever that b number is. So what I have here are a coefficient of a in front of u and a coefficient of negative 2/5 b in front of u. So you can kind of think of this as factoring, but I'm going to take the factor of u to the end. It's like my common factor, and I'm pulling the coefficients to the front. Right? But it's kind of like you could be thinking about u as a common factor, so we pulled it out, but we just write it at the end here since it's not a coefficient. All right, so now what I have is I want to turn vector u, which is not a zero vector. I want to turn it into a zero vector. So that tells me that I must be multiplying the magnitude by 0. So this tells me then that I need a minus 2/5 b to equal 0. And at this point, I've lost the vector notation. So this here is a vector 0. And this here, I'm just talking about what am I multiplying vector u by? I'm multiplying it by the number, or the scalar, 0. So here I've only taken, what I've said is this thing needs to equal the number 0. All right, so now we need to solve this equation. And so I can pull over the 2/5 and add it to the other side. And I get that a has to be equal to 2/5 of whatever the b number is. Now, there's many possible answers to this situation. I don't have enough information to come down to one possible answer. This question asked me to find some pair of values that will work. So what I find is easiest is start with the more complicated side and choose a value for b. And then we're going to calculate the value for a. Remember, there's lots of different answers here. I know that's going to make some people uncomfortable, but it's okay. So we're going to say if b is equal to, now when you pick your number for b, pick a number that you can easily find 2/5 of. So pick a number that divides by 5 really nicely. So maybe I pick 10, because I know that 10 divided by 5 is just 2. and then I would have 2 times 2 left. Right? I get a 2 here, and then I get a is equal to 4. So this is one possible pair of values that, that you could use to solve this equation. Somebody else is going to give me a different answer. Somebody else is going to say, well, I'm just going to use 5 because that'll divide really nicely. And so when they divide theirs out, they just get a 1 here, and they get that a is equal to 2. And so you can see that there are actually an infinite number of answers. But we were just asked for 1, so I'm just going to say, therefore, a equals 4 and b equals 10 satisfies the equation. All right, that's it for today's lesson. Have fun with the homework.